Okay, now let us go to the seventh one. So the graph shows the variation in distance of a horizontal force acting on an object. The object initially at rest moves horizontally to a distance of 50 meters. Let us understand the graph first and then we will read the further of the question. So you see the force, a constant, not constant, a variable force, 0, 10 Newton, 20 Newton and so on. Variable force is kept on applying on an object until, you see, until 2.5 meters here, until 2.5 meters, 0 to 5 meters until 2.5 meters. And after that the force is slowly reduced. What is the maximum force applied at this point? 80 Newton. And after that the force is slowly reduced until 5. Then what happens? Okay, when the force here in this region from here to here, there is no force applied but still the object is moving. But here once again the force is applied and once again it comes like this. So like this you are applying spikes of forces over here, and the question is, okay, it continues to move until a distance of 50 meters, and it also has a friction. A constant frictional force of 2 Newton is opposing the motion. That means constantly there is a frictional force acting. What is the final kinetic energy of the object after it has moved 50 meters? This definitely will take some time, don't worry. Okay, so towards it. Now first thing is, what we will do is, he has asked you about the final kinetic energy. Whenever the problem is about the energies, you need to work using energies only. So towards it. Now what we do is, we find out what is the work done by the applied forces. Work done by the applied force, you cannot use force into displacement. You should not use this. Why? Because you see the forces are varying, right? So and this is a graphical representation given. Find out the area of this particular triangle. What will be the area of this triangle? Let me write it down. It should be a half multiplied by, what is the height? 80 multiplied by the base 5, right? In a similar way, I have 3 different triangles over here. So what am I finding now? I am only finding down the work done by the forces, external force, multiplied by 3 triangles, okay? Which should be 2 1s are 2 40s are 40 into 5 is 200, 200 into 3 is 600 joules. So 600 joules is nothing but the work done by the external forces. Okay. Now at the same time what's happening is, as the object starts moving, there is a constant force of 2 Newton opposing the motion of the object. And to what distance? Until 50 meters. Which means the work done due to friction is equal to force multiplied by displacement. Why should I apply this? Because it's a constant force, right? 2 Newton multiplied by 50, which is equal to 100 joules. And how is it acting? The force is now trying to take up this energy over here. 600 joules is the energy on the object, but while the friction tries to remove that energy. So therefore the net work done is equal to 600 minus 100, which should be equal to 500 joules. Okay. So this question has to be done in a very careful manner. Okay. Now the answer is 500 joules. Let us move on to the